Number 37 on page 215 puts together the last part of the notes, which is about polynomials of odd degree and also the idea of having an irreducible quadratic factor. Now this leads to two things. First of all, the fact that because it's odd degree and we have a third degree polynomial, we're only going to have one real root, and then the other part is going to be a quadratic, and we're going to see that it's irreducible, which would mean we have two complex roots for a total of 3 roots that we would expect with the fundamental theorem of algebra. There really is no difference between doing this problem and any of the others we have done. We're going to start by making a list of possible rational zeros, finding a zero, dividing it out, and then we'll have our answer. So let's make our list. So our p factors are going to come from the 2, which is the constant, so plus or minus 1, plus or minus 2. Then our q's come from the leading coefficient, and we have just plus or minus 1. So our p over q is going to be just our p factors, plus or minus 1, plus or minus 2. Now we're going to use these factors, and we only have 4, to find a 0 using the factor theorem. So I tried a bunch of these out, and I found that f equals 2 worked, gave me a 0. So now I'm going to use that in synthetic division to divide out that root. And we'll see that what we have left is going to be a quadratic that we cannot factor, and if we were to use a quadratic formula, that our roots would be complex. So we are left with f of x being our x minus 2 from our real root, and then we have the irreducible quadratic, which is x squared plus x plus 1. And we're not asked to find all the zeros, so that's as far as you have to take this problem.